In this video, you are going to see what happens when you narrow your field of view over a long distance. This will confirm unequivocally that compression of distant objects does occur when you narrow your field of view. I'm going to play two portions of this video right now, followed by the entire video at the end of the demonstration. From an elevation here of approximately 30 feet, I zoom into the Stena Hibernia, leaving Heysham and heading for the Isle of Man. It passes right in front of Peel Castle. So by using ship AIS, I can confirm its distance away by plotting its route on Google Earth. I have taken a screenshot, and here we have an overlay, which I place onto Google Earth, and we have a distance to the boat of 6.3 miles. And this distance might be useful in further research. Now, each step is 6 inches high, and I lower my elevation to 1 foot above actual sea level or thereabouts. Now yes, curve calcs say 17 feet should be hidden, and clearly this is not the case. But this is not what this video is about. This video is about what can we see, can we prove what we see, and what is happening to the image. Luckily, this boat has very identifiable markers: blues, whites, oranges, and words. By means of these markers, we can assess both elevation data. Most important of all the data is 2 factors: the length of the boat when scaling, and the orange hull. The orange hull proves we are seeing right down to the waterline, and is a fantastic guide for measuring. I take 2 still shots of the 30-foot and 1-foot elevations and compare them. What is evident that when placing both boats at the same length, we see drastic differences in height. This becomes much more pronounced the lower down the image we go. The top part of the image is nowhere near as compressed as the lower part. It seems, and the evidence backs this up, that the narrower the viewing angle, the greater the compression. Take a look. The orange hull is visible on both, proving we are seeing all of the boat. Look at the height of the words, drastically smaller on the narrower angle. There is no denying that the image of the boat at the narrowest angle is severely compressed. How does this help us understand the flat Earth? Well, we hear often that boats go over the horizon. What if they just go into the narrowest angle and the boat's hull suffers compression? The further the boat goes away from the observer, the more of the boat gets into that very narrow angle. More of the boat gets compressed, yet the higher part of the boat, sitting in an area with a greater viewing angle, does not suffer the same compression as the hull. This effect on our eyes and cameras will make it appear that the boat is going over a curve, when alternative research such as this show it to be just compression. You can see the evidence with your own eyes here. Nothing has been altered. All this does is show you the effects of optics and a lowering of the viewing angle over distance. We don't need to see how much is hidden. We don't need the curvature calcs. These are simply for reference. So I will reiterate that this is all to do with compression. The height of the hull to the top of the boat versus the length of the boat. We can clearly see that the narrower the angle, the more compressed the boat's hull gets, whilst out of that narrow viewing angle, the top part of the boat stays relatively the same height. So again, this is not an exercise in the curvature calcs. This is not an exercise in how much of the hull we can or cannot see. We know we are seeing all of the boat. The fact we can see the orange hull proves this. This is beyond question. I'll just play the entire video for you now so you can see for yourself. The only thing we need to concentrate on here is the compression of the boat.
So this boat is passing right in front of the Stena line. From an elevation right now of approximately 30 feet plus, perhaps nearer 40 feet. And I'm going to go and see if I can see it at 1 foot. Let's rush. So here's where I'm going to be resting my camera, on this ledge with it underneath my fingers. I'm going to lie down now on this step. It's at high tide. And let's see what we can see. There she blows. At under a foot. Where's the Stena line gone? So here's where my camera is. I'm just going to pull away. And there's where the tide is. 3 inches perhaps. I hope you enjoyed that one from Ranty, and I'll see you again.